Have you ever just stopped and wondered, how does something unbelievably complex, say a life-saving miracle procedure, go off without a hitch every single time? How do teams of people juggle thousands of steps when the stakes are literally life and death and not make a single mistake? All right, let's really get into it. Take something like a hematopoietic stem cell transplant. The complexity is just staggering. You've got patients, donors, specialized labs, timing that has to be perfect down to the minute. One mistake? Not an option. So, how do they pull it off? Well, it's not magic, and it's not just about having brilliant people on staff. It's all about the system they work within. So, the answer, it turns out, is something called process management. It sounds kind of corporate, I know, but to really get a feel for how it works, we're not going to start in some sterile, high-tech hospital. Nope. We're going to start somewhere a lot more familiar. We're going to a bakery.
Yeah, you heard me right. Baking bread. It sounds crazy, but this simple analogy is honestly the perfect way to understand the core ideas behind ensuring top-notch quality, whether you're making a loaf of sourdough or, yes, performing a bone marrow transplant.
Think about it. When you bake bread, you don't just throw things together randomly, right? You've got your inputs, your flour, water, yeast, salt. You've got a very specific procedure, the mixing, the kneading, letting it rise. You've got your equipment, your oven and pans, and it's all aimed at one clear goal, a delicious, perfect loaf of bread. And that right there, that whole goal-directed sequence of events, that's a process. So that brings us to the official textbooky definition. But really, a process is just a structured way to get from point A to point B. The key things to hang on to here are goal-directed, you're trying to achieve something specific, and interrelated, which just means every step is connected and builds on the last one. Okay, so how do you make sure every baker in your shop makes that same amazing bread every single time? Simple. You give them a recipe. And in this world of quality management, that recipe gets a fancy name, a standard operating procedure. We just call it an SOP. It's basically the instruction manual that spells out the exact steps so nothing is left up to guesswork. And this is a really key point to understand. There's a difference between a policy and a procedure. A policy is the why. It's the big picture goal. For our bakery, it's something like, we are committed to making high-quality bread. But the SOP, that's the how. That's the nitty-gritty. Bake at 200 degrees for 30 minutes. See the difference? One's the big dream, the other's the step-by-step guide to get there. Okay, so we've got our basic toolkit now, right? We know what a process is, what an SOP is, and the difference with a policy. So let's say goodbye to the bakery and take these exact same ideas into the much, much more complex world of hematopoietic stem cell transplants. You know how a really fancy recipe has different parts? Like first, make the filling, then make the crust. Well, it's the same idea here. This incredibly complicated transplant process is broken down into smaller, more manageable sub-processes. We're going to look at 3 of the big ones. So first up is the clinical process. This is basically everything that involves the patient directly. We're talking about all the prep work, the day-to-day care, the constant monitoring, all of it handled by the doctors and nurses. And you better believe they're following some incredibly detailed procedures.
Then you have the collection process. This is where the donor comes in. There's a whole separate, specialized team using some seriously high-tech gear like an apheresis machine, and their one and only job is to collect those life-saving stem cells. And just like with the patient, their every move is guided by a super specific SOP. And finally, step 3, the processing process. Those collected cells are rushed to a lab. Technicians in these ultra-clean rooms take over. They might be freezing the cells, cleaning them up, labeling them. Every single step here is absolutely critical. Get one thing wrong and the whole transplant could fail. Okay, so we've got all these super complex, super standardized processes. Great. But how do you know they're actually working? How do you measure if you're doing a good job? More importantly, how do you spot a tiny problem before it blows up into a disaster? Well, that is where this cool idea of the quality thermometer comes into play. This quote from the source material just nails the concept perfectly. It's like a thermometer. If the reading is too high or too low, well, it's like having a fever. It tells you there's a problem that you need to investigate and treat. You don't just cross your fingers and hope for the best. You are actively taking the system's temperature. And this thermometer has a name, of course. It's called an indicator. Now, this isn't just any old number you're tracking.
An indicator is a very specific measurement taken at a super critical point in the process, and it has to fall within a certain range. And here's the absolute key. If that number goes outside the range, it's not just that's interesting. It automatically triggers an action. You have to do something about it.
This is such an important difference to get, a simple metric versus a real quality indicator. For example, tracking the number of transplants per year. That's just a measure of activity. If the number is low one year, does that mean your quality is bad? Probably not. It doesn't force you to do anything. But a quality indicator like graft failure rate, now we're talking. If your target is 5% or less and it hits 6%, ding, 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 that's a fever. That's a clear signal that something is wrong and you need to jump on it right now. So let's make this even more real. What would these indicators actually look like for our 3 stages? Well, for the clinical side, you might track the percentage of patients whose new immune system kicks in by a certain day. For collection, you'd measure how often you successfully get the right number of cells. And for processing, a huge one is cell viability. What percentage of cells are still alive and kicking after you thaw them out? See, they're all things you can measure, and they all tell you if the system is healthy. But here's the thing. This is not a set it and forget it kind of system. Not at all. The real magic of process management is that it's a living, breathing tool that's all about one thing: continuous improvement.
Teams will literally use tables just like this to keep an eye on their indicators. So check out that first line, graft failure rate. The target is less than or equal to 5%. Quarter 1, 4.8%. We're golden. But look at quarter 2. It creeps up to 5.1%. Red flag. The system immediately flags it. And look over in the action column. They launched an investigation to figure out what went wrong. That's the system healing itself, right there in real time.
And these indicators, they aren't carved in stone. The whole thing is dynamic, constantly evolving. If a new risk pops up, hey, you can create a new indicator to watch it. If a team gets so good they're smashing their target every single time, well, you can make the target even harder, pushing them to get even better. It's a system that is always adapting and always pushing towards perfection.
And you know what's absolutely crucial? None of this happens in a vacuum. The results from these indicators are shared with everyone: the clinical team, the collection team, the lab team. That transparency is everything. It makes sure that everyone, from the head doctor all the way to the newest lab tech, knows what the goal is and is working from the exact same playbook.
So there you have it. This is how perfection is actually engineered. It's a systematic, data-driven approach used in some of the most high-stakes fields imaginable. And that just leaves us with one final, kind of provocative thought to chew on. If we can define, measure, and manage quality this precisely in medicine, what does it say about all the other areas of our lives or other industries where we don't?